Okay, this lesson is a little bit of a review for inverse trig. I'm going to remind you of things you should know. You should know the 30, 60, 90 triangle has sides. Some of you will use 1, root 3, and 2. 60 degrees is up there. Some of you will use x root 3, and 2x. And some of you will have 1 half root 3 over 2 and 1. The 45, 45, 90 triangle will have, for some of you, root 2, 2. Some of you will remember it as x root 2. Some of you will remember it as root 2 over 2, root 2 over 2, and 1. I really don't care which ones you know, you just should know them. Remember that 30 is the same thing as pi over 6, 60 is pi over 3, and 45 is the same thing as pi over 4. So what is inverse trig? We know. Well, hopefully you remember. The sine, let's say, of pi over 6 is 1/2. Opposite over hypotenuse, using the 30-degree angle as your reference angle. Inverse trig, inverse function, say you put in your y value and you get back out your x value. So for an inverse trig, and you're probably used to this notation, you'd say inverse sine of 1/2 equals pi over 6. Inverse sine of root 2 over 2 is pi over 4. Inverse cos of 1/2 is pi over 3. What you're doing here, that little -1, a good phrase is to say to yourself, what angle has a? So when we look at this problem right here, what angle has a sine of 1/2? And then if we go back here, sine is opposite over hypotenuse, that would be it. Looking at this problem, what angle has a sine of root 2 over 2? Go back here, sine being opposite over hypotenuse, 45 degrees. I'd like you to answer in radians though. What angle, let's look at the third one, what angle has a cosine of 1/2 is pi over 3. When you first learned inverse trig last year, you also learned that there are limitations. These three functions, inverse cos, inverse secant, and inverse cotangent, you are only allowed to give your answer in one of two places, either in quadrant 1 or in quadrant 2. If x is positive, you give the answer in quadrant 1. If x is negative, you give the answer in quadrant 2. So, for instance, what angle has a cosine of root 2 over 2? We know that's 45 degrees, pi over 4. What angle has a cosine of negative root 2 over 2? You give the pi over 4 in quadrant 2, that is 3 pi over 4. Quadrant 3 is no man's land. No function ever goes into there. The other three functions, inverse sine, inverse cosecant, and inverse tangent, also have limitations. Their limitations are quadrant 1 or quadrant 4, but by going clockwise. So, what angle has a sine of root 2 over 2? That would be 45 degrees, which is the same thing as pi over 4. What angle has a sine of negative root 2 over 2? That is the pi over 4 in quadrant 4, but you have to go clockwise. If you're really interested in why, it's a longer explanation. It's probably just best to accept you can only go quadrant 1 or quadrant 4 clockwise. Again, quadrant 3 is no man's land. You may not travel past quadrant. You can't go into quadrant 3 ever with inverse trig. The last thing to remember, because these do sometimes also come up, is your quadrantals. And to remember that you just start by labeling the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Those are your x, y values. Those are also your cosine and sine values. So let's see. Let's do what angle. Let's see. I'll do this one. Oops. I don't know why that didn't work. Inverse cos of negative 1. What angle has a cosine of negative 1? Look over here, all the way over. That's pi. What angle has a sine of negative 1? Oh, there it is, down at the bottom, but we are not allowed to go. Stop, you can't go that direction. You have to go this way to negative pi over 2. Okay? Make sure you have your notes, bring them to class tomorrow, and it will help as we do our inverse trig problems.